First of all, I'd like to thank everyone for attending our presentations, the second half, and I'll go ahead and proceed just talking a little bit about my experience with TxDOT. So I've been here for a whole 6.5 months, and this right here is just a picture of our traffic department. What I'm about to present to you all was not only my work, it was a team effort, right? We all participated also with the help of TTI on this program call. I'll be presenting the innovative safety project analysis, our innovative safety project analysis from the Corpus Christi district, and also towards the end of the presentation we'll have Yanni from TTI join us. So I will be presenting the tools and techniques we used to identify the projects qualifying for this safety improvement program call. That's our table of contents. I'll go over the introduction, just basically a brief description of the call. Our analysis. There are 4 different steps that we took for this analysis, and I'll close it off with the conclusion of our summary. Okay, so just a brief description of our program call is, of course, the goal is to achieve a significant reduction in traffic fatalities and serious injuries on our roads. This program is federally funded, and the crash source that we use is the Crash Records Information System, better known as CRIS. For this year's call, there were 7 categories: the whiten, grade separation, curve, texturing, intersection, off system, and the HSIP. Also on the word codes and the project documentations that we had to submit for this call consisted of your SII report, which was just a benefit cost analysis, and your estimate. Depending on which category you were submitting for, there were also other requirements to submit, like typical sections, intersection layouts, or warrants. Okay, for our safety project analysis, we divided our analysis into 4 different steps. We had our data processing, our development of the maps, the project identification, and the identification of project limits for submission. And I'll go ahead and start off with our data processing. We used various software for this step. We used Microsoft Excel, ArcGIS, ArcCatalog. Okay. So our first step, of course, as you all may know, then for this call we ran a report on CRIS, generating a report for the last 3 current years of crash data, which was 2011 through 2013, and what we did after that was that we imported this data that was generated on CRIS to a spreadsheet that we created, which identifies the applicable countermeasures. You'll see here are statements. All these up here are our work codes. So this spreadsheet identifies the applicable countermeasures for each accident. And you can see them right here. Okay, then later what we did was that we imported this information into our catalog and processed the data. Then that was transferred or imported to ArcGIS. And in ArcGIS, we filtered our data, then created layers for each work code. And while we created the layers, we defined are symbols for each type of crash. For example, here you can see that these are all our crashes, fatal and incapacitating, for this program's call, which were from year 2011 through 2013. Your red dots are your incapacitating accidents, and your black dots are your fatals. Here's another example, just demonstrating how we were able to define symbols for each category per work code, and this appears demonstrating work codes 304, 305, and 514. Also, it's important that I mention that we used ArcGIS as a tool to process the data, not so much to view or analyze the accidents, but to process our data. Okay, and here is a different map, and this map here is showing our work codes for texturing 532, 533, and 542. And also, I'd like to mention that you can see down here, this is our rumble strips master plan. So basically what this map is showing us is that we are able to plot all the accidents applicable for these work codes for the call, but we can also plot segments of roadways that have been implemented with these countermeasures, and the yellow are for future implementation, and the green are the ones that have already been implemented. Okay, for our step 2, then we went ahead and developed our maps. Here you can see this is just a map displaying our narrow roadways, and basically during this process what we did was that most of these maps were also printed, and we handed hard copies to mainly our area engineers. That way they could review these maps and have a better idea of the projects that they were considering for submission for each category. Besides our district maps, we also went ahead and created maps for just counties. That came in handy because we were able to hand those maps out just depending on area engineers section. And this map is displaying the work codes for traffic signals 107, work code 108, and work code 111. Okay, here's another map of the work codes for a county. This is Nueces County, and it's displaying work codes for 514 and 515. Okay, and for our step 3, then we moved on to the project identifications. During this process, basically, we were able to meet with the area engineers, and using Google Earth, we were able to identify project limits. And here is basically just showing how from ArcGIS, we were able to create layers to import to Google Earth. And Google Earth, it was the tool we used to identify our project limits. go ahead and show a brief demo of the procedures that we followed in order for the project limit identifications using Google Earth. Okay. Here I'm displaying our work code 303 for the whole district. And as I mentioned before, your red dots are your incapacitating accidents and your black dots are your fatals. Okay. Now here you can see it's a better demonstration of how our defined symbols. Here we are plotting your high friction surface treatments at curves, which are your circles, and also your high friction surface treatments at intersections. And also other features that we are able to use using Google Earth is an attribute table, and on this table we are able to have our, for example, just your type of crash, your roadway, time, location, or different attributes like light condition, weather condition, manner of collision. Also, on this attribute table, you can see that this will tell you if this accident is applicable for any other countermeasure, any other work code. For example, this specific accident is applicable to work code 122 as well, 124, 128, 129. And I'll talk a little bit more about the process. What we did was that we set up meetings with our area engineers, and we were able to use these layers, go through their sections, and select project limits, project segments for each of the roadways or locations of concerns. Okay. Here you can see I'm plotting our centerline texturing work code for 542. And also we're able to bring our master plan in, and this helps us during the process. That way we don't resubmit any projects that have already been submitted or awarded. Okay. And here now we're displaying our project submitted for texturizing. So all of these were projects we submitted for texturizing, and your yellow ones are for future consideration, and your green ones are the ones that have been implemented. Also, we have other features like bringing in your reference markers that comes in handy when you're selecting your projects for project limits. Okay, let's see. Okay. Well, as you can see, this process is a lot more user-friendly than ArcGIS. We were able to use Google Earth to not only view our accidents or plot our accidents, but also identify project limits for submission. Here I have a picture of this accident which occurred this year, July 1st. Nueces County. It was an incapacitating accident, and using this process we were able not only to, I know depending on different districts there may be rural or urban, but using this method we're able to cover all our district and identify projects not only rural roads but also urban, and this will probably be a project that we will be using for next year's call. You can see a qualify for convert median barrier. Okay, so our last step was the identification of project limits, and for this step TTI helped us create a what-if analysis or a backward calculation for our SII values, and we have Yanni who will be explaining a little more on the spreadsheet.
Hello from me. I'm Yannis Tsapakis from TTI. So what I'm going to show you here is a live demonstration of an Excel file that was used to calculate SII, which is the main criterion used to select projects, and also do some backward calculations, do some what-if scenarios, and try to understand what are the factors that affect the SII, to what extent, and what you can do to optimize the project limits. I think it would be easier for you if you see the Excel file and we go through an example together, and that would be also easy for me to explain to you what this Excel file does. So let's assume for a minute that we identified by using the Google Earth layers a project, and this project involves centerline texturing. Here you can either select by using the drop-down menu the specific work code that you're interested in, and then the spreadsheet automatically populates for you some important items that go into the SII calculation. So you don't have to look at the text manual and manually enter these numbers into this formula. These fields include obviously the work code description, the category where this specific work code belongs, the reduction factor, service life, maintenance cost, and many more that are not shown here. After that, you know the number of crashes that you will consider for a candidate project. So let's assume that there was one fatal crash and zero incapacitating or non-incapacitating. Then the next thing you need to do is to assume a growth rate. The current AADT cancels out the future AADT in the SII formula. So it doesn't really matter whether you put 1,000 or 10,000 or 1 million. What really matters is the growth rate. And then we move to the probably most important part of the Excel file, which is the backward SII calculations. Mariela mentioned that at the beginning. SII, for those who are not familiar with the term, is the safety improvement index, and it's a benefit cost ratio. And there's lots of different factors in the numerator and the denominator of the SII. For that specific candidate project that I'm working on, Ismail might ask me, okay, what was the previous year's cutoff SII? Because I'm curious and I just want to know as the baseline. So the spreadsheet will generate the 2013 cutoff SII, and somebody who wants to take a conservative scenario might say, well, I want the new project to have an SII higher than the previous year's cutoff SII by 20%, for example. So you would do that, and then the target SII that the project is going to have is that much. Somebody might say, well, I don't care about the previous year's cutoff SII because these are going to change. There's a lot of factors behind the whole process, and I'm sure that this year, and Darren McDonald can confirm that the cutoff SIIs will significantly change, and might say, well, I don't care about these two numbers. I just want my project to be over 1.5 or 2 or whatever he wants. So he just plugs in whatever value he thinks would be enough to allow him to have the project funded. Based on the target SII, the spreadsheet tells you what the maximum total cost of the project needs to be so as to meet the minimum SII. And based on that, and assuming that you know the unit cost of this specific work code, centered line texturing, what is that? Is it 10,000 approximately? So the cost to do centered line texturing per mile is 10,000, and the next cell tells you that you can do 93 miles of center line texturing that will allow you to submit the project with an SII higher than your target SII. And of course, you saw I entered a few values here and there, and you can explore and do some what-if scenarios, how the safety cushion is going to change the cost, hence is going to change the length of the candidate project. Or you can change, for example, the number of accidents involved and include 2 more incapacitating crashes that happen 5 miles down the road. And you want to know how the SII is going to be affected in that case and how much the cost is going to increase. So by exploring these different options, then at the end of the day, you're going and you're just entering the total right-of-way and construction cost of the project, which has to be lower than that. So let's assume that it is 2.5 million. Then the actual SII that you're going to put in the final report that you will submit to Darren McDonald is going to be 1.43, which is higher than the target SII. We didn't really use extensively this Excel file, and it's still work in progress, but there is a potential, and for sure it saves some computational time. It is worth mentioning but that by using these simple techniques and tools, it's not rocket science, Ismail's team managed to identify 153 projects within 2 days, I believe. So that was a big achievement and saved you a lot of time and effort. I think that's it. You have a few more slides to present?
Okay, classes. Okay. So our program call summary. Here you can see for each of the categories, winding, grade separation curve, texturing, intersection off system, and HSIP, we submitted a total of 148 projects for this year's call. 63 of those projects were awarded, totaling $23.3 million that were awarded to our district this year. And here's just a pie chart of our 7 different categories and what was awarded per category. Texturizing being our category with most projects awarded. Here next is a map. We were able to map our projects awarded for this year, and what we plan to do with these maps is use these maps for next year's call to verify that we don't resubmit or projects that have already been awarded for this year's call. Okay, so why use these tools and techniques? Applying these tools and techniques, the Corpus Christi district was able to achieve an improvement of 250% improvement for projects submitted, 385% improvement for our projects awarded, and 133% improvement for the amount funded. As you can see, for last year's call, it pretty much doubled for this year's, using these tools and techniques. And here's our contact information, mine or Hyannis's, in case anyone has any questions, but we'll probably be open for questions towards the end. And that's just a picture of us. That concludes my presentation.